So generally, Sir Isaac Newton was a famous scientist renowned for his work on the laws of motion. One law states that for an object falling vertically in a vacuum, the rate of change of velocity with respect to time t is a constant. Okay, write down in dE, dE relating to this. So the rate of change, which is dv dt, is a constant c. So the rate of change is just dv dt equals to c. That's why in physics, right, definition is important, because with one definition you can set up an equation. Okay, so that's it. So initially the velocity of the object is 4 meter per second, and after a further 2.5 seconds, so it is 4 meter per second, then further 2.5 seconds, the velocity of the object is 2.5 seconds is 29. So at t 2.5 v is 29. Find v in terms of t and set the value of c. I think it's not too bad. You just need to solve this d. This is obviously separable form, right? So you move the dt the other side, like that, the other side. Then you just add an integral sign. You can put a 1 here. Okay. So this is just v ct plus, let's say, d then. Initially, so t0, I put t0, v is 4. This will be d is equals to 4. So when t is 2.5, v is 29. There you go. That will be 29, 2.5 t plus 4, which means 2.5 c. This will give us c equals to 10. So hence v is equals to 10 t plus 4. And c is equals to 10. I'll read this question properly and understand what's going on. For an object vertically through an atmosphere, the rate of change of velocity. So now read this and careful. The rate of change of velocity is actually less than that of for an object falling in vacuum. So falling in vacuum was this, right? dv dt, the dv dt equals to c. So the new rate of change is modeled as a difference between the value of c found, which is 10. Difference c and the amount proportional amount proportional to velocity v, proportional with a constant proportionality of k, meaning this is kv. Okay, so what they are trying to say is dv dt is modeled as a difference, so it's equal difference between 10 minus kv. Okay, 10 minus kv, that's what they're saying. So the difference between 10 minus something proportional to v. So this is the new dE. Okay, this is what it says. So dv dt is given by 10 minus kv. I think just solve this is fine. This is separable, so just move this over. So 10 minus kv dt, so ln 10 minus kv divided by negative k equals to t plus c, negative kt plus c equals to ln 10 minus kv. Open up the ln, plus minus, so plus minus e minus kc, e minus kt, 10 minus kv. This guy, everything is constant, just replace a constant in. Just assume that it's an arbitrary constant. This will give us 10 minus kv equals to a e minus kt. We were told that initial velocity is 0. So when t is 0, we know that v is 0. V is 0. So it's 10 minus 0, a, e 0. So a is just 10. 10 minus kv equals to 10 e minus kt. Make v the subject. kv. It. You were told that An object falling through atmosphere, right, which is the new D that we solved just now, the terminal velocity is the value approached by the velocity after a long time. So this means t goes to infinity, right? So we told that t goes to infinity, the terminal velocity is actually 40 meter per second. Okay, so find how long it takes to reach 90% of its terminal velocity. Okay, that's the question. So essentially, we write it down. Given that as t goes to infinity, we know that v will tend to 40 meter per second. Okay, 40 meter per second. So essentially here, what we do is we also know that e minus kt, since k is a positive constant. Okay, this is important. If k is positive, means this will go to 0. K is positive, right? Yeah. Then basically 10 over k, v will just tend to from this equation here, 10 over k 1 minus 0. So hence it just be 10 over k. So 10 over k will just be 40. Yeah? So k will just be 1/4. So what we need to do is essentially what we ask ourselves at velocity is equals to 90% of terminal velocity. Okay, what is the time taken? So you just take 90% times 40, which is 36. Now with the k and this equation, we can solve what as our t. So we know that the velocity now v is equals to 10 over 1/4 1 minus e minus 1/4 t. So just solve it, shouldn't be an issue. So when v equals to 36 meter per second, this will be 10 over 1/4, which is 40. E minus, solve for the t. Then we're going to log both sides. Log 1/10. There you go. The exact value is 4 log 10. The time used is in seconds, right? So it's 4 log 10 seconds. Okay, or you can leave it in 3SF, which is 9.21 seconds. Okay, either way is fine.